that's by the top.
How would I know
That's
what
all. That's piece of
All right, Leela,
Yes,
you need 1033, baby.
I do.
And then I gotta go print you something. So you don't feel left out, like you're not part of the group.
Oh, thanks.
Anything for you. All right. Which class are you in, baby? No, I
Tuesday.
You're Tuesday, Thursday. So you did complex fractions yesterday?
Yes.
Okay. So let's start you out here. Let's go 9 minus x over x squared plus x minus 90. Okay. Let's go 4 over x plus 3 over x squared plus 7x. Okay. And then let's go 5 over x minus 7 minus 3 over x plus 2. Let's try those three. Okay, we'll start you out with those three.
We don't want the X mark.
Can you see the whole thing?
Like technically you do, but you divide it.
All right.
Okay, so like.
Are we ready?
Yeah, sure. It's good enough.
I mean, you can keep explaining it if you want.
Well, no, you can probably do it better than I can. This is like your job.
All right. F of x equals 0. When we look at f of x equals 0, what we're looking for is when does the graph cross the x-axis, right? So, and that may label all kinds of points. The only one I'm interested in is the x-axis. So when is f of x equal to 0? That is at 1/3. Okay, that's when it's equal to 0. Now, when is f of x greater than 0? It is greater than 0 from negative infinity to 1/3 and from 1 to infinity. Okay, this part is above the axis, this part is above the axis. And that's what we're looking at. Greater than 0 meaning above the axis, negative infinity to 1/3, union 1 to infinity. Okay. How sweet. All right. And a chocolate milk.
And napkins.
And napkins? That dude, unbelievable. That's the Polish. I didn't get anything, Mel. F of x is less or equal to 0. When's it below the axis? Now, the number one wrong answer I see, and I know why you put it, but it doesn't make it right. The number one wrong answer I see, negative infinity to 1/3. It's not negative infinity. I know it's going down and I know it's going to negative infinity, but we're looking at the x values. When you say negative infinity, you're saying the y value at that point. So we are talking about 1/3 to 1. We are talking about 1/3 to 1. Now, going forward, let us understand this, Jasmine. We can never, ever, 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 and by ever, ever, I mean ever, ever. We can never, ever put a bracket on a vertical asymptote. Ever. Ever. If you do that shit and they ask you who you had, tell them, Lee Joe. I am not taking credit for that. The vertical asymptote will always be a parenthesis. Always. Because the graph can never cross the vertical asymptote. If this is a vertical asymptote, you'll never see it go like this. You know what? I don't care. I'm going to go through. It cannot happen. Okay? Now, 1/3, that will get a bracket because it's equal to 0 at 1/3. All right? We good? Now, what's the domain? What's the domain? Ashley, what'd you get? Nice. Negative infinity to 1, union 1 to infinity. All right, Philip, what's up?
I have the answer for the next one.
Okay, what's the range?
And negative infinity to 3, union 3 to infinity.
Union 3 to infinity, we good? We good on that? Alright. For the next one, we're gonna multiply both sides by x minus 4. Now we can do that as long as it's equal to. If it's greater than, less than, that becomes a no-no. Okay, greater than, less than, that becomes a no-no. But we can do that as long as it's equal. We'll cancel this. We'll get 3x plus 5 equals 7x minus 28. That is if we distribute. Subtract 3x, add 28, add 28. Gives me a final result of 4x equals 33. And x is equal to 33 over 4. All right. Brad, we good?
Good.
We good? Christian, we good? Christian, what did you get for the last one?
9 and 5 over 2.
5 over 2 or negative 5 over 2?
Well, it's negative 5 over 2, but I didn't put 5 over 2.
Alright, so with this one, you got x equals 9, we're here. X equals negative 5 halves, we're here. Again, I'm making a number line there. Alright, negative 5 halves and 9. We're going to plot numbers to the left of negative 5 halves and between negative 5 halves and 9, and then we're going to plot a number to the right of 9. When I look at a number to the left of negative 5 halves, look, you don't have to get that close because it doesn't really matter, and I'll be honest, sometimes the bigger number you choose, the easier it is to see. Like if I choose negative 20, which is way out here, negative 20 is pretty easy to see generally. 2 times negative 20 is negative 40, plus 5 is a negative number. Does that make sense? Negative 20 minus 9 is negative 29. That's a negative number. And so what I get is a negative number divided by a negative number, and that is a positive number. Bless you. Bless you. Between negative 5 halves and 9, we'll call that 0. This is positive, this is negative, the inside part's negative. And to the right of 9, we'll call it 30. 2 times 30 is 60, plus 5 is positive. 30 minus 9 is positive. And that is that. What you'll notice is that most of the time, and I say most of the time long, this is the general setup that you'll see. It usually goes positive, negative, positive. The only time you'll see that switch is if this were like 2x plus 5 over 9 minus x. That will switch it around and become negative, positive, negative. Okay? But generally, if it's like this, it's almost always positive, negative, positive. Okay? And I said generally. Okay? Not forever, generally. All right, bless you, baby.
Thank you.
All right.
Wait, so I didn't write this over there.
Yes.
Oh, my bad. Negative infinity, negative 5 halves. Union 9 to infinity. Union 9 to infinity. Morning, DJ. Morning, Dan. You guys grab a donut. All right. Because Brad and I are not eating while we Brad.
Nope.
Laser focused.
Yep.
All right. Questions, comments, concerns? What's wrong?
Oh, no, you got your camera. You're good, bro.
Yeah.
Is it working?
No.
Oh.
Oh,
That's actually his. I don't know.
Looks good though.
Well, you know
That's
what?
the prop you got.
He might be getting a Hero 8 and I might be getting a Hero 7.
Cool.
We'll see.
Might be how it is.
We might have to just make that happen.
how is it a negative 80 to negative 5?
Say it again, please.
How is it negative 50 to 5 over 2?
Because that's the critical value for this. 2x plus 5 is negative 5 halves if you set equal to 0. You're setting this and this equal to 0, and that gives you these two numbers.
Cause it said when is x less than 0, so wouldn't it be just?
Oh no, it said greater than 0. You didn't see that? Have another donut. Any questions on that? My bad, Christian. Erase, 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 erase.
Wait, so that's the answer?
Yeah,
Wait, what? I thought.
I screwed it up, my fault. I mean, I'd like to blame somebody, but I can only blame Philip so many times before it gets old. If I would've had a donut this morning, it would not have happened though.
Is that?
Laser focus.
Laser.
Is your blood sugar low right now?
No,
You deserve it.
I'm too fat for that every day.
Is that a bracket on the negative part?
No, baby, it's a parenthesis.
Yep.
This is equal to, well, let's say.
Can we do one more like that?
Yeah, I think we can. Can I erase this? Everybody got it?
Yep.
Anybody want to take a picture? Lasts longer. All right. Hey Jacob, how you doing on your problem I gave you?
Pretty good. You're gonna have to give me a little bit though.
I think it works, but hell, I don't know. Did you work it up? Keep working, Jacob. Try it. Here. 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 Oh. Y'all showed up, I should probably write something on the board. See, I wrote it in anticipation y'all were gonna be here. Hey, why couldn't we get Will up for this? Does Will stay in the same apartment y'all do? He must not need to, I guess. Alright, so here's what we're gonna do. We're gonna look at, the average temperature. We're gonna look at the average temperature, in March. And we're gonna say that the average is 81 degrees. Alright, we're gonna say the standard deviation is 2 degrees. Alright. And we want to find the probability that we pick a day and it's more than 75. We want to find the probability that it's less than 82. We want to find the probability that 4 days have an average more than 83. And we want to find the top 5%. All right, so let's just start y'all there. All right. Hey Jacob, how far have you gotten? If I change the 4 to a 5, how much does that screw you up?
Where? Oh, at the bottom?
If I change that 4 to a
I know you're right.
8, how bad does that screw you up?
I mean,
From here to here.
I'm already past the part where I was looking at that for.
You'll thank me later.
Pick one.
Great. I'll have to wait till later to thank you though.
My bad, Jacob. Leela,
Yes.
what'd you get for the first one?
1 over x plus 10.
Oh, no.
Oh, you're so close.
No? Okay.
No?
So,
Only for you.
bottom part is x plus 10, x minus 9. That part you got, I'm assuming, yeah?
Yes.
Well, how did you cancel this?
We didn't do that.
Or did you just cancel it and call it good?
The negative out. because
You
it's-
pulled the negative out.
Yeah.
Now let me ask you a question, where did the negative go?
Ah. Yeah. It's supposed to be there.
Check your pocket, maybe you put it in there.
Yeah. Yeah.
Definitely, right?
Well, because I think the last time we had those kind of problems, I think you just forgot about it. Not forgot about it.
I forgot about it?
No, like something happened to it.
Oh, I don't know, it might
Because it
have.
was one of the ones where we added.
Oh, yeah. So,
So I thought we just forget about the negative.
fair enough. So, what you saw the other time when we did it, was these two were basically the same. I pulled the negative out. I didn't forget about it. I took this and combined them together. And turned that to a plus sign.
Okay.
So that's why it gave the appearance like I just forgot about it.
If it would have been a plus already.
It would turn to a
you
minus
make
sign,
it negative?
yes.
I see now.
Okay, so yeah, no, we didn't just ignore it. We,
Oh.
we dealt with it.
No.
Alright,
Yeah, I'll have to go back to some notes real quick.
alright, we good?
Yeah.
Now, for this, you have x and x plus 7. The common denominator then becomes what?
X.
X.
7?
And x plus 7.
Okay, yeah.
So here I got the x,
Then you have to give it x plus 7.
then I gotta give it the x plus 7. If I put the x plus 7 on the bottom, I gotta put it, Brentley, can we see this okay?
Oh, so it works?
Hey, listen, this is a high-tech organization you're dealing with right here.
Just a question. I'm trying to offend him.
That's why I was just asking Brantley. This stamps are facing over there, but Brantley assures me that it's working. So if he says it, I believe it. And the further I get to the right, the more I know it's gonna be in focus. All right? We good?
Yep.
Now from there, what did you get?
7. Oh.
4x plus,
3.
See,
no, what did you get?
Well,
What was your final answer, baby?
My final answer was 7x, x plus 7 over x plus 7.
How'd you get 7x?
Because I put the x plus 7 to the 3 as well,
yeah, that makes.
Oh, no.
which is a no-no.
No. This has already got the x plus 7 on the bottom. So there's no reason to put it on top.
Okay, yeah, I don't know why I was throwing.
Wrong, wait.
Okay? No, it's okay. This is why you're here. It's 4x plus 28
Thanks, you just copy what I did.
plus 3, which is 4x plus 31 over x plus 7. No, this is why you're here, baby.
Ah, okay,
Okay?
alright,
So if you don't have it, you have to put it. If you do have it, you leave it alone.
makes sense.
Okay, let's just start from scratch.
All right?
With the room.
All right, how about this one?
I got 2x minus 11 over x minus 7, x plus 2.
I just said with it, and you said it.
What was the last number?
2, x plus 2, no?
X plus 31.
31.
Common denominator is x minus 7 and x plus 2. Do you agree?
Yes,
So I got the x minus 7. What am I missing?
So that'd be the answer, that would be, just do that.
the
Wait,
x
no,
plus 2.
no, it wouldn't. Yes.
So if I put the x plus 2 on the bottom, I must also put it.
Where is that?
That's
Yeah, see, that's, I got that.
I got the x plus 2. What am I missing?
the x plus 7
If I put it on bottom, I must also put it.
on top. That's what I
So it
did.
should be negative infinity.
But here's what you didn't do.
Wait,
Well,
you put
yeah,
plus
Have you
up.
done it?
Why do you put plus up?
That's a good question.
Here's what you didn't do. I bet you anything. You did not write it like this first. You distributed first. Did you distribute 5x plus 10, 3x minus 21?
Yeah.
Don't do that.
Okay.
Here's the reason why. When you distribute 5x plus 10, that part makes you feel real warm and fuzzy inside.
Right, right.
The place that you screw it up at is very small, very minor,
Oh, yeah.
but it's a screw up nonetheless.
But the negative 4 thing.
Negative 3x plus 21. The number one place that people make a mistake, Leela, is right here. That plus sign.
Yeah.
They must always make it a minus sign. And it's a result of it's a result of distributing the 3 before you bring it this way.
Yes.
Because if you distribute the 3, you get 3x minus 21. And you never get the minus sign distributed the way you're supposed to. If you write it this way, you're much more likely to distribute negative 3 times x, negative 3 times negative 7.
Yeah.
So you almost just kind of have to, almost like driving, you know what I mean? Sometimes you just got to slow it down
Yeah.
and relax, slow it down, and you'll be okay. You speed through it, well, bad things can happen.
Gotcha.
All right. Well, the good news is with this, you just missed the problem.
Yeah.
Driving might be a little worse.
I got x equals negative 1/5.
From there, you get 2x plus 31
You get that too.
over x plus 2, x plus 7.
You didn't get the 1/5? Oh, man. Oh.
Yep.
All right.
I was on the right track.
You didn't get.
All right, let's try some more then.
Okay.
We'll do
Can you
them.
leave the bottom there so I can?
Yeah, absolutely.
Write that out.
Are we gonna raise the top two?
Yes. Jacob,
You about ready for your work that?
Just about, give me,
It's finished. Okay, and this is
Let's just try those two, Lila.
Okay.
All right.
If we take it online, I'm a math teacher, I'll just like write it down, slip pages, like that.
Take it online. Should be easier on
I hope he doesn't do like where like you have to like film yourself. You know what I'm talking about?
Oh, that's so weird.
It's just like you have to do like a 360 scan of the entire room. And, you're like there's like a little person. You're like you go around the room, like show off, and you have to like take a picture of your face, put your little ID up there. Yeah, exactly. And they're like,
Oh, wouldn't even be there. Yeah.
it's 3 weeks off.
Well, that's because there was a I can't learn online.
You already know it, so like.
No, I can't. I can like be there and learn it. And if I need to ask a question, I gotta ask it. I can't learn from computer. I'm getting
Yeah, be like you sit there and you're like, no, I'd be like doing stuff right now. Versus at home.
Yeah.
Yeah.
What's that one spot you guys go to?
Which was
The one
on the book?
Yeah.
The roof one? Yeah, it's on like LV. Like by Legoland, like so. It was like built on like 7th Street, and then they nailed it in like 2x4s that you can like crawl up the tree. And then you go.
I've never been.
Really? Yeah, we can go. I think they're planning like a big lake day, so like everybody has a boat. Because since school's canceled, like, why not?
Yeah. Just get on going to work together, right?
Yeah, pretty much. Who cares? We're from Florida. I will be. That's why the boys and girls club, yeah.
So you swear.
They closed it. Like, no, they didn't like firm have it, but somebody that worked there was in contact with somebody that had it. So like at the cost of renovation. Yeah, because yesterday when they like they're on the outskirts, they're like, by the way, if anybody rides the boys and girls bus, find a way home. They ain't coming. Yeah. And they're all like, they're deep clean like that. So like they mop, but they don't mop like the edges. So like the middle's clean, but like under there, like. Because they were like, they had a little mask on. Yeah, I think everything's a blur. Ooh, here's some stitches.
But always talking about the coronavirus, because look, this is not what we did, like, here.
Holy straight.
Yeah.
Very much.
Yeah.
It's so close to everything.
Same thing, look, when I was there, that's when they started closing like all the. It's the same thing with she was back by you? No, yesterday.
Yeah, my sister's coming home because like she goes to UF and they're like,
Every day or yeah.
no, come down. Obviously, she's like, hey, cool.
Yeah, what? I don't know what you get for the second one. He didn't even
So,
get it.
so I get it.
Look, Andrew's
I don't wanna get it though, like,
She already had the flu this year, but I can't get it.
yeah, I heard it wasn't any worse than the flu vaccine.
Kid. He's literally shining light on anybody that has it.
You like walk through
You don't gotta do it.
Exactly, the reason why I don't want it is because I.
If you want somebody to get away, just I'll talk to you.
Now, but like, if it's just static noise,
On YouTube, there's I think there's a way to stream it. I was watching a YouTube video. Leela?
Yes.
There's this one thing, it's called Ultra, it's like an EDM. They go, people that are my brothers and stuff, so they already bought their tickets, so they already bought them.
The dude, like, yeah. I'll be ready then. I was ready. Everybody like one piece. Everybody like just gonna go. Anyway. Some girls. Like on the back on the beach when they get up. Like, oh,
Right.
that doesn't look.
Right. What is it?
Yeah, one of my basketball players. On a ventilator and good at all.
Teaches everybody going to.
I don't think he was driving. Kids who think that cars are toys have any repercussions for driving fucking crazy as hell. Huh?
Get hit by a bolt.
No, just young kids, sometimes they think cars are like fun gadgets.
Yeah.
You know what I'm saying? Like toys, like
drive fast.
drive fast, drive reckless. I don't think he was driving, but you know, I don't even know what happened. He may have gotten run off the road by a semi. I don't know. I don't have any idea. But I know it's scary. All right. Dan and DJ, y'all ready? I'll explain these to you. All right. Before I do that though, well, y'all are still working or y'all done? Y'all done? Yes. All right. Let me quickly work these. And I'll do those. This one, we got -4/3, and then -7/2. Yeah.
Yup.
Right? Plugging in test points. This is positive. This is negative. This is positive. I don't want to go through the whole thing. Is that okay?
Yeah.
When's it greater or equal to 0? Negative infinity to -7/2. That's going to be a parenthesis. Union -4/3. That will be a bracket. Long.
I was in on that side.
Say it again. Yeah. Yeah. It's positive, negative, positive. -4/3 is equal to 0. -7/2 is an asymptote. You can never put a bracket on a vertical asymptote. You plug in -7/2, it doesn't work. Yeah. Now, when is this less than or equal to 0? In order to solve, or less than 6, in order to solve this, we first solve this. 5x plus 1 is less than 6. 5x plus 1 is equal to 6. We square both sides, we square both sides. 5x plus 1 equals 36. 5x equals 35, and x is equal to 7. Right? Now, this graph goes this way. There's 6. That point is 7, yes? 7 comma 6. Where does it start at? What's this bottom point? -1/5. It's -1/5. Do we agree? All right, so when's it less than 6? Less than 6 from -1/5 to 7. 7 is going to get a parenthesis because that's when it's equal to 6, not less than. -1/5 will get a bracket because at -1/5 this is 0 and 0 is in fact less than 6. Okay. Bracket -1/5 to 7. Did I what, baby? So all square root graphs are functionally this shape. The question that you have to ask yourself actually is which way does it shift? In this case, it shifts to the left, -1/5. Set that equal to 0. Okay? Then it crosses right there, and that point 7. When's it greater or equal to 6? That would be from 7 to very ugly.
Screwed me up, Mr. Drier.
I told you to fix it, and you would thank me later. You're
I
welcome.
was already halfway to the problem.
Well, you were gonna get it right. All right, is he good? I can give him the next one?
Probably wants.
All right, any questions on this? Any questions on this? Going once, going twice? Let's have some fun. You didn't wake up on Friday morning just to like come in here, get 6 right, easy wins, and then feel good about yourself.
Oh.
So you woke up early on Friday, challenged. Let's challenge you. F of x equals 16 minus x squared. X squared minus 8x minus 9. Cube root of 2x squared minus 8. 4 minus 3x. Let's find the domain for all of those. All right, Dan, DJ, here we go. So when you do these, first of all, you got to recognize that this is the formula you're using. X minus mu over sigma. Okay? The only thing that happens, and the only time you use something slightly different, is if you don't have one thing, you have more than one. This is 1 day, this is 1 day, this is 4 days. If you have more than one, then you're using this. Now, if you think about it, Dan, you could functionally use this every time because 1 day would be n is 1, and then you would divide by 1, and that would still be sigma. Okay? So if you have to memorize either this or this, memorize this, and then plug it in as 1. All right? But generally, most people just memorize both of them. Okay? Now, more than 75. This is 81. This is 75, and we're doing more than that. Okay? Now, the way, DJ, we go over it, and the way we talked about it is, we have 2 charts. We have a positive chart, and we have a negative chart. We use them equally, but we don't use them based on the z-score being positive or negative. We use them based on large area and small area. So if the picture I'm looking at is a small area, and by small area I mean less than half, and it can be less than half on either side. If it's less than half, I use a negative chart. So no matter what the sign is, if it's less than half, I use a negative chart. If it's more than half, meaning this one is more than half, or if it was more than half this way, that will get the positive chart. Does that make sense? So, is that the way he taught it, or did he teach you to subtract 1 when you needed to? Okay, that way's terrible. Do it my way. Way better. Just know that you got to look at the chart, and you got to pay attention to which one you're using. Okay? So 75 minus 81 divided by 2. That's going to be negative 3. We are at negative 3, I get that part. But it's a big area. So I go straight to the positive chart, it gives me the answer. What do you look up 3? Dan, you agree? 0.9987. Okay? Now, if I'm going to do less than 82, this is 75, this is 82. Oh shit, no. Dump button, right? This is 82. Don't think anybody watching? Good. All right. 82 minus 81 over 2, yeah? That's 1 over 2, which is 0.5, yeah? You did what? Oh, you put 75 in the middle? How would you got 80? You put 75 in the middle. If you put 75 in the middle, you get 3.5. All right? Now, positive chart, negative chart. Why? Big area. I want your head to start thinking about the size of the area, Dan. Okay? If not, I feel like you're probably always going to be floundering around, and you'll get some right. I hate to say this, but by luck. Kind of like you know, have teammates sometimes who shoot it and they make it, and you just look at it and go like this. That was luck, right? But then, you know, you'll get enough right to make you feel like you're doing okay, but you'll never get enough right to pass. Big area, small area. Big area, positive chart. Small area, negative chart. All right? So look up 0.5. What do you get?
0.6915.
0.6915?
Yeah.
I have no reason to doubt you. Ryan, did you look that up? I'll believe what you said. I don't know. I don't feel like looking at it. 4 days have an average more than 83. So again, we're 81, we're 83, we're going here now.
That's small area.
Small area, so which chart? Negative chart. Negative chart. So 83 minus 81 divided by 2 divided by the square root of 4.
Oh, yeah.
We have a size now, so we got to divide by the square root.
Yeah.
So 83 minus 81 is 2. So we got 2 divided by 2 divided by the square root of 4, right? When you type that into your calculator, you don't have a big boy calculator?
I'm not sure.
You don't have a good one? Does he make you use that, or does he let you use the TI-83?
I think I really didn't need last night. Fancy one.
After this is over, let's get together. I'm gonna see what I can do.
I can't. I'm going.
2 divided by 2 square roots of 4.
Yeah.
2 divided by the square root of 4. 2 divided by the square root of 4.
Why do you do these? The old question.
This is just your only question? Just how to do all of them?
Pretty much, yeah.
Ryan, can you go help him? Yeah, Ryan's standing right here.
They don't like me.
Well, no, because like, no, I did it, and then he told me it was wrong. I said, why is it wrong? He said,
I want to clarify, he's probably me.
yeah.
Because he has not asked me anything.
Okay.
No.
I was going to say, dang, Ryan, I mean, like we bring you to be nice, not like to be like, you're wrong. Why? Because you didn't do it the way he does it. We need to get you a big boy calculator. When you type that in, you're going to do it like this. 83 minus 81 is going to be in parentheses. Then you're going to divide, and you're going to open parentheses. 2 divided by the square root of 4. Now, if you can do that in your head, that's great. If not, that's fine. What you end up getting is 2. You end up getting 2 right there. Now, are you going to use the positive chart or negative chart, DJ? Why? So this picture right here is more than half the graph. This is what you got to look at. This is why you're here. It's less than half, yeah? So which chart are you going to use? All right, so look up -2. What do you get? I don't want you to think I don't trust you, but I'm going to look too. Go ahead. Look up -2. What do you get? 0.0228. What confuses you? Yeah, I know I shaded to the right, but look at the picture. Is this more than half of the whole graph, or is it less than half the whole graph? Right? Like, This is half, right? This is half. Is that picture more or less than the half? Less than the half. All right? Less than the half. And that's why, honestly, you've got to pay attention to how you draw this, because, you know, I've had students who put 81 right here and then put 83 over here. Well, then, now it's more than half and it screws up the whole picture. Does that make sense? You got to pay attention. All right, top 5%. How do you do it?
X minus 8.
Top 5%. This area is 0.05, yes?
Always.
Now, if it's a top percentage, we use a positive number. If it's the bottom percentage, we use a negative number. Okay? So this is 1.645. So 1.645 equals x minus 81 divided by 2. Yeah? Multiply both sides by 2. You get 3.29. With x minus 81? Yeah.
How do you cancel 1? 5 by 81?
Add 81. Add 81. So 84.29 is x. Give me one second. Hey, look. Do this one. All right, you guys good? Before we move on to confidence intervals, let's do one more set like that and give you a little more practice, all right? Y'all good? Can I erase it?
Can I use like all one? You can place like top.
Okay, so I'm gonna leave the top 5%.
Well,
This one?
yeah, I can.
Okay.
Yeah, thank you.
All right. So let's say the mean is 22,500. Let's say the standard deviation is 1,000. We're looking at the price of cars. Okay. Let's find the probability a car costs less than 20,000. Let's say more than 19,800. Let's pick 10. Find the probability average is more than 23,000. All right, try those. All right, Leland, be right there. Hold on. Jacob, here we go.
Yes, sir.
So we got 1, 2, negative 1, 6. We got 2, negative 1, 2, 6. 3, 1, negative 3, 8. All right. When you do this, we're trying to get rid of these first. Okay. It's negative 2 times this row. Negative 2 times this added to this. Yeah.
Oh, yeah. Bottom.
Okay, so you did negative 3 times this and added to this. Left the 1, 2, negative 1 on top? Leave the 1, 2, negative 1 on top, or did you change that? So, negative 3 times this added to this. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 2 is negative 6, plus 1 is negative 5. Negative 3 times negative 1 is positive 3, minus 3 is 0. That worked out nice. Negative 3 times 6 is negative 18, plus 8 is negative 10. Agree? Negative 2 times this added to this. Negative 2 times 1 is negative 2, add to this, you get 0. Negative 2 times 2 is negative 4, minus 1 is negative 5. Negative 2 times this is positive 2, plus 2 is 4. Negative 2 times 6 is negative 12, plus 6 is negative 6. Now, negative 1, yeah, switch these two around. All right. Negative 1 times this, add straight down. Negative 1 times this, you'll get 0, 0, 4, 4. You agree?
What do you do about this?
Right? Now, 4, 4 become 1. Divide this by 4. Then divide this by negative 5. Yeah. Now, finish it off. Multiply this by negative 2, add up. Add straight up. Make sense? Do that. You get Right. Gotta go.
But there was, finding the end.
Which one? 2 by 2 or 3 by 3? 2 by 2 is easy. 3 by 3 is hard. 4 by 4 is bad. Alright. So let's do this. Let's do this. Let's do this. Let me give you A equals 5, 3, negative 2, 6. Let me give you B equals 4, X, Y, negative 1. Right? Let's find A plus B. Let's find A times B. Let's find the determinant of A. And let's find the inverse of A. Alright? Fun stuff. Alright, Leela. Leela. Let's go, baby. Here we go. You're going to erase the bottom part?
Yes.
Alright, with this one. Common denominator is x plus 6, x minus 3. X plus 6, x minus 3. So you got 7, x minus 3 over your common denominator.
Yes.
Minus 4, x plus 6 over your common denominator, yeah?
Yes.
Now, again, what I would like to see you do is write it this way. Not North Korea though, I can't force you to do it. Alright? I feel bad about that, Brad. Alright? What I would like to see you do is write it like this. Okay? 7x minus 21, negative 4x minus 24. 7x minus 4x is 3x. Minus 45 over the common denominator. Right? Now, be careful here. Be careful here, because technically we can factor the 3 out. Okay? If you factor out the 3, get x minus 15 over x plus 6, x minus 3. But you have to be careful with Leland. You haven't seen a lot of it. Now, it may happen, Leland, that this and one of these will cancel. And that's why it becomes so important that you factor. Either one of these is fine. Don't have to factor, but you have to factor if it will reduce, and you don't know if it reduces until you factor. Does that make sense? So kind of a paradigm there, right? Like, if it reduces, you have to factor, but you have to factor to see if it reduces. If it doesn't reduce, you have to factor to start with. So you always factor it to see. That'd be the same. Both pieces have to be the same. Yes. Yeah, and this would be x plus 6, they would cancel. If this were x minus 6 and this were x plus 6, they would not cancel. Got to be identical. Here. Common denominator is x plus 2, x plus 3. Do we agree?
Yes.
All right, so due to time constraints, we're just going to fast forward our broadcast. This is 9x plus 3, 2x plus 2. Yeah. Now, this is where you got to be careful of, baby, because you got minus, this needs to go in parentheses.
Yes.
That needs to go in parentheses. All over common denominator, yeah? So this is 9x plus 27, 2x plus 4, minus 5x minus 6. Again, this is the one that people tend to mess up on. Okay? This is the one that people tend to mess up on. 9x, 11x, 6x,
Yes.
27, 31, 25.
Yep.
Now, that's not going to factor, so we're good. Yep. All right. Now, let's look at this one. This one beat your butt.
Yeah, it did.
Yeah, I know. You know how I know? It beats everybody's butt.
Yeah.
I think it beat Brad's butt when he was in that class. Oh. Can I erase these?
Yes.
I tell you, if you're watching at home, to press pause, but rewind. You press pause. Common denominator, what is it?
AB.
What is it? Well, so here's what I would like for you to do. Multiply up, multiply up, multiply over, yeah?
That's fine.
So b squared plus a squared over a squared b squared, yeah?
Ah. Yes. I put AB squared together.
Oh, if you do ab squared, you gotta put it in parentheses.
Yeah, didn't do. Yep.
Multiply up, multiply up, multiply over. B minus a over ab, right? Now, what we're gonna do? Keep, change, flip. Keep, change, flip. A and a squared cancel, b squared cancel, yeah? Yeah. So what you're left with is b squared plus a squared over ab times b minus a. B squared plus a squared is on top.
I get the top.
This a and one of those a squareds will cancel. This b and one of those b squareds will cancel. So this part is just ab on the bottom.
Yes.
So it's ab times this part.
Okay.
Good? Now let's try this. Let's try this, and then let's give you a preview of what's ahead. Okay, you got time? All right, Race?
Yes.
So let's go 1 over x squared minus 1 over y squared, 1 over x minus 1 over y. Okay? And then let's solve 3 over x plus 6 equals 5 over x minus 4.
That's ahead.
Yeah. Yeah, this is look ahead.
Okay.
All right, we'll be doing it next week. Jason, did he get you? Camera adds like 40 pounds. Just, I mean, I'm down 2.4 pounds right now. Feeling very healthy right now, Brad. Are you down this morning, Brad?
I was 100 calories under.
Good job. I was 1,000. Just so you know. Yeah, I'm fat though. I get a lot. All right.
Like 5,000.
When you're fat, Jasmine, they're like 6,000 calories to lose weight. All right. So what do we do here, Ashley? What do we do here? We're setting the inside
Greater than or equal to 0.
greater than or equal to 0.
Okay, it's 19.
So we're setting 16 minus x squared greater than or equal to 0. What does that graph look like?
A negative or a negative.
It's a parabola. Concave down, yeah? This is -4 and 4. Do we agree?
Cool.
So when's it greater than or equal to 0? -4 to 4. Oh, shoot.
You have to judge that because I just did.
I did that.
No, you can do a design graph too. All right. That is a parabola. It's concave down.
Okay, but.
And this is -4 to 4. Yes, ma'am. Bracket. All right. All right. Setting this greater than or equal to 0. This is a parabola. Concave up. This is x minus 9, x plus 1. That makes this point -1 and this point +9. Right, Christian? Now, when's it greater than or equal to 0?
Oh, yeah. 9 bracket.
Negative infinity, -1, union 9 to infinity. Good? By the way, I'm going to post this on campus. Assuming that we are here on Monday, and all indications are that we will be here on Monday, we're going to do pizza and problems on Monday next week. That way, for those of you that have the test on Tuesday. Okay. All right. Well, that way we can look at it on Monday. I've got a meeting at 3 o'clock or something. Say it again, please. No, Monday afternoon at 1:15 we'll have pizza and problems. Okay. If you're around. If you're not around. I'll post it on campus. All right. So we'll go Monday, Tuesday next week for pizza and problems and SOS. All right. All right. Now the third one, what did you get?
This is negative infinity to infinity.
Negative infinity to positive infinity. Don't get roped into doing a bunch of work here. Okay, that's my dad used to call it fool's work. All right. I'd be doing something. He was like, "Man, you're doing fool's work." What does that mean? You're wasting your time. Oh, man. Don't waste your time. All the stuff. Oh, it's greater than concave up crosses at 2, -2. Yeah, okay, good, great, good job. The answer is negative infinity to infinity. It's a cube root. The only time it wouldn't be would be if this were under a fraction, but you're not going to see that in this. That's beyond the scope of this. How about this one? Negative infinity to 4/3. Positive 4/3. You're setting 4 minus 3x greater than or equal to 0. Negative 3x is greater than or equal to -4. X is less than or equal to 4/3. Good? Negative infinity, 4/3. I got time for one more?
Yes,
Yes, sir.
Yeah.
give it to.
Oh, yeah, also.
Mom just called. We gotta drive my dog.
Horizontal asymptote, vertical asymptote, x-intercept, y-intercept, domain. Y'all will thank me later.
Yep.
Be able to handle it for sure. Alright,
We proceed.
DJ, Dan, y'all ready?
Yeah.
Alright, so probability of one costs less than 20,000. 22,500. 20,000, we're going less than that, yeah? Now, ask the question, big area, small area?
Small.
Jacob, you done?
Just put a zero.
Well, how do you know you're all right? No, the line thing is the way I do 3x3.
Oh. Yeah.
Hang out or leave and ask me next time. 20,000 minus 22,500.
Mr. Drier.
Hey, buddy. Love you. Take care.
1,000.
Over 1,000, yeah?
That's, C is,
Negative 2 point,
negative 2.5.
2 point.
5.
You got what?
Negative 2.5.
Okay, I agree. Are you using the positive chart or the negative chart?
Negative.
Why? Why is it negative?
Smaller.
Small area. DJ.
I did. Oh, I'm at.
It's less than half the graph, DJ.
You're right. Got the right answer.
That's, 0.062.
I have no reason to doubt you. More than 19,800. Here's 19,800. This is 22,500. More than that, yeah?
If they're safe.
That's 2,700. Over 1,000, which is 2.7. We agree, it's negative though, yeah?
Negative.
Negative 2.7, yeah. Now, you use the positive chart or the negative chart? Why positive?
It's bigger.
There you go. What'd you get?
0.9965.
DJ, you get that? Alright, so we're gonna pick 10. More than 23,000.
We're using N in this one, right?
Say it again, please.
We're using N in this formula.
So it's 23,000
I already keep
minus 22,500 over 1,000 over the square root of 10. So that's a half. The square root of 10 is around 3.2, so that's a half. Looks like it's gonna be around 1.6.
1.58.
Dan, what you have to understand about me is I only estimate. I'm never right. I'm usually pretty damn close. Alright, 1.58. Now, DJ. Positive chart, negative chart. If you screw this up, I'm gonna throw my mark at your forehead. I ain't even lying about that. You ask better duck. Why? Okay. Somehow I think you might have just gotten lucky right there. I feel like that might have been the between the legs, behind the back, throw it over your head shit. Alright? You didn't see it. My man TK went between the legs with a reverse off the backboard, like, it was crazy as hell. Hey, Dan, was it lucky or was it skill? Good players seem to get lucky more often. How about that? 1.58. Negative chart, what do you get?
0.0570.
0. What?
0.0570.
Why is it 0? It's 0.571, yeah?
0.0570.
The hell chart you looking at? You're a dope chart.
I got 2. I got -2. So it's
That's insane. Alright. So, I'm assuming that probably most of the time they're the same, but yours is slightly different. Alright? Any questions on that? We good? DJ, you good on this? DJ, for you, page 3. This is all it. All you gotta do is know that formula and be able to look at big area, small area. Bada bing, bada boom. Alright? Now, let's finish you guys off with the confidence interval. Alright? So, sample of 45 people. 29 have their own car. Alright? So out of 45 people, 29 of them have their own car. Use this to construct a 95% confidence interval population proportion. Dan, have y'all done the mean too for this, or have you just done proportions?
Not even the split T proportions and the other one. I'm not
oh yeah.
Yeah, all our class has only done proportions so far. We're gonna be doing means probably after spring break.
We don't even the cheese.
Chi-square?
Yeah.
You've done that?
Yeah.
Okay, good for him. All right.
Can you give me like one example for T1 and
I don't know what you're doing. Let me see a problem. Do you have an example problem?
Oh.
I got the T.
We'll write that over here, Dan.
Excellent.
So we're gonna look at the sample 25 people. Okay, we're gonna sample 25 people. We're gonna find the average cost to fill up the car. The average price to fill up their car, $28.19. Okay. Let's say the standard deviation is $1.85. Okay. Construct a 90% confidence interval for Leela.
Yes.
We're on to you, yeah, baby?
Yeah.
All right. over, yeah?
Yep.
So y squared minus x squared over x squared y squared. Do we agree?
Yes.
Up, over, yeah? Y minus x over xy. Right? Now, what do? Keep, change, flip. Yeah? Now, x squared cancel. Y squared cancel. Leave me with y squared minus x squared over y minus x. Now, you did not, I hope, just go like this. I got people who do it all the time. Not gonna lie, Jason was one of those guys a couple years ago.
Sure. I had that.
Leila, how did you simplify? Or did you not?
Yeah.
I,
That's on the bottom, right? The xy is on the bottom?
yes.
You stop right there? How about y plus x, y minus x over xy, y minus x? I didn't. God's will. Y plus x over xy. Love you. All right. Look ahead. What did you get? Try it.
I tried it. Got negative.
Okay. We're solving this. So we're trying to get x equals something.
Well,
Okay. Let's take a look. Common denominator is x plus 6, x minus 4. We're going to multiply through by that. So when we solve problems that look like this, Leela, we want to clear the fractions. So we're multiplying both sides. We're canceling this. We're getting 3x minus 4. We're canceling this. We're getting 5x plus 6.
what was it negative?
X minus 4, yeah. That changes everything. But you want to make it positive? We can keep going. I mean, I don't care.
Sure.
All right, let's just make it a positive.
Okay.
Make this a positive. All right? Problem solved. That's okay.
So like,
Not an issue. 3x plus 12 equals 5x plus 30. Subtract 3x, subtract 3x. 12 is equal to 2x plus 30. Subtract 30, subtract 30. Negative 18 equals 2x. Divide by 2, divide by 2, x equals negative 9. Did you say negative 9 or positive 9?
That's what I got.
Okay, so yeah, you just messed up the sign there, which is not that big of a deal. The process is the same.
Right.
So yeah, you're good. Okay, now it's going to get a little more complicated than this. We're going to add a third term. Okay, so it'll be this equals this plus something else. But the idea, Leela, will not change. Whatever the common denominator is, we multiply through, we clear the fractions, and then we solve whatever equation we have left over.
Okay. The answer is negative.
Yep, negative 9. Now, the last thing I need to tell you is that we should check the negative 9 and make sure that the denominator is not 0. That happens about 1 out of 6 times.
How?
Negative 9 plus 6 is negative 3. That's not 0, so that's a good thing. Negative 9 plus 4 is not 0, so that's a good thing. All right. Leila, we're going to leave you with that.
well, I don't even know. But
All right. College algebra, here we go. Alright. Here's what you have to recognize, college algebra guys. 2x plus 1 cubed. And this is as extreme as a problem as you would get. Are you going to get one this hard? Probably not. Would you get 2x plus 1 squared? Maybe, definitely so. So the concept, I think, is still important to you. Okay? What you have to recognize is that if you were to expand this out, this leading coefficient would be 8x cubed.
Thank you.
You're welcome, baby. We'll see you later on. Okay? If this is 8x cubed and this is x cubed, the degree on top and the degree on bottom are the same, and the horizontal asymptote would then become y equals 8 over 1, which would just be 8. Okay? The vertical asymptote is still going to occur whenever the bottom is equal to 0. The bottom is equal to 0. If you factor out the x, you get x squared minus 5x minus 14. That gives me x minus 7 and x plus 2 if I factor. If you need to use the quadratic formula, go right ahead. Ultimately, you're going to get 7 and negative 2. This one will be 0.
So negative? Or do we not count this?
Yeah, you do. So the vertical asymptotes would be x equals negative 2, x equals 0, and x equals 7. You'd have 3 vertical asymptotes.
What's the x?
Because of the x. If x is 0, 0 times all of this will still be 0. Huh? For these?
Oh.
Remember, we're setting x equal to 0, we're setting x minus 7 equal to 0, we're setting x plus 2 equal to 0. Know what you mean? X equals 0 doesn't solve. X equals 7. X equals negative 2. Those are your 3 vertical asymptotes. That's when we good? Now, x-intercept occurs when what?
One half.
When the top is equal to 0. In this case, that would occur at negative 1/2, 0. Right. Just said equal to 0. If this times itself 3 times is 0, then x is negative 1/2.
Can I get a replay?
So, yeah, you're taking 2x plus 1 cubed. You're setting it equal to 0, right? Which is functionally 2x plus 1, 2x plus 1, 2x plus 1 is equal to 0, yeah?
Yes, sir.
Which really is 2x plus 1 equals 0, 2x plus 1 is equal to 0, and 2x plus 1 is equal to 0, yeah? So what's x? It's just negative 1/2 all 3 times. Do we agree? Negative 1/2 all 3 times. So the x-intercept is negative 1/2. Later on in pre-calculus, applied calculus, you'll hear things like multiplicity. And they'll say the it's negative 1/3 with multiplicity 3. That just means that there's 3 factors for it, and that's it's not that big of a deal, but negative 1/2 with multiplicity. Y-intercept, what is it? 1 over 0, so it's undefined. There is no y-intercept. It's not. Yeah, if you plug in x is 0, 2 times 0 is 0, plus 1 is 1. Cube that, you get 1. 0, 0, 0 over 0. Hey, Brantley, do we have anybody watching this morning? I mean, there was somebody at one point, and then they got tired?
It's 0 just. It's quantified.
Undefined because it's
None or un-
the answer is none. If you wrote undefined, I'd give you credit, I'd give Ashley credit. Brad. Brad's chasing that elusive 100. Feels like Bigfoot right now. He feels like it's only a rumor that it exists. Gavin would like to tell you that he's found it a couple times. All right. Come on. Domain. What is it?
Negative infinity to negative 7.
You don't put the zeros in?
Oh yeah, 0, yeah.
Jasmine, you got that?
Yeah.
Did you really?
Yeah, I did.
Props to you. No, she didn't get the mark of shame. Did you get it right?
The other one.
Of course.
Get the mark of it.
Yeah, you just draw a smile.
Yeah. All right, Brad, did you get it right? Don't lie, Brad. Math way? Math way? No. Sort of math. Okay. All right, any questions on that? Knowledge algebra, I'll leave you guys with that. All right. Thank you guys for coming.
I think you should still go to Miami.
No. Why not? That's like,
I was in Miami last
that's like the coronavirus capital right there, right now.
No, it really is. You can go over there.
I'm still gonna go on the cruise. All right.
That's worse.
You only live once, so.
You only live once.
On the down beach.
I'm just saying, like, you die on the beach when you're 80, not when you're
Apparently
20.
since yesterday, there were
Either way.
2 reports in Pinellas and 1 in Paso.
Dude, it's gonna be bad. Exponential growth.
Yeah.
That's all.
Are you, so you're still really going to that Greek?
Do what?
Are you still really going to that Greek?
Probably not. I have a lot of respect for my cousin. And she was like, Steve, it's bad.
Yeah,
And I'm like, she's like, I canceled my vacation, you should probably cancel yours too. And I'm like, well, crap. If you care enough to cancel your vacation, I probably should cancel mine too. But right now, I haven't canceled yet. I'm still thinking about upgrading my suite.
You're gonna be the only one in that boat.
Have you seen how cheap plane tickets are?
Yeah. She's done a lot of research on it. She tells me.
Andrew just sent me an article.
Yep. Laser focus.
Yep.
You gotta stay focused, Brad.
Yep. I had 10 pita chips with hummus yesterday. 410 calories.
You don't think about it.
No, I'm gonna have to start taking just one. That's a good tip.
So we're still having SOS next week.
Yeah, SOS, pizza and problems will be on Monday, SOS will be on Tuesday. Alright, I've got a meeting Monday afternoon at 3 o'clock, so I figure I might as well do pizza and problems one.
Okay.
And our test is on Wednesday.
This is on Wednesday. I feel very cheapy right now.
I don't. I answer. I got my answer. You work with me.
What's PHAP? How do you find it? Walk me through it, you got it, so let me walk me through it.
Oh, let me take my notes. Can I take my notes?
No, tell me about it.
I gotta take. I can walk you through. I just gotta take my notes.
29 over 45, what does that equal to? What is it? 0.64. Part A, you draw a picture. 0.95, 0.025.
Like the little space is like 1.9.
Yeah,
or something like that.
1.96.
96.
There's hope for you, DJ. Might turn you into a statistician before long. What's the formula? You got 20 bucks right now if you give me the formula.
He had. With the little hat thing.
You come right.
No, go ahead.
You come right. You can, cause you're gonna, I'm paying 20 bucks. I got you right here. Dan's like, how do I get on that? You can't.
Yeah,
You're
I'm
in my
gonna
class. Like, I'm gonna do it.
wrong.
Yeah, I got 20 bucks right now. Go.
Alright. P hat, right?
Uh-huh. Go ahead. No, you get it. I'm paying you $20. I ain't saying shit.
Minus E.
Write something down, man. Now the whole room's watching.
Greater than sign. P. Nah, fuck, I messed up, right? I messed up.
Nah, good, keep going.
Nah, I messed up.
You tapping up?
Alright? I'm saying, was I heading in the right direction?
Yeah.
You right?
You're just right. Yeah, I'm blocking your ass. I thought we were on the same team here, Brandon.
Nah, I'm done.
You're right.
Is this the
Oh,
one that,
shit, hold on.
is it mu or p? Because this is confident.
Brandon's on my team.
Let's say yes or no.
Brantley and Ryan are on my team. Hurry up, I gotta go.
Was alright?
Somebody's gotta go.
They're not even.
They don't know they're not done.
Alright.
Go ahead, Brantley.
Should be p hat minus less than p, which is less than p hat plus e, where e equals the z score times the square root of
See?
Target 10 then?
No, you tapped out. You tapped out. Part C. Going back. Maybe I'll come up with another deal for you.
Damn, I should have kept going.
You should have. Why did you tap out?
Bye.
Bye, guys. We'll see you later on. So it's 0.64 minus 1.96 times square root of 0.64 times 0.36 divided by 45. 0.64 plus 1.96 times the square root of 0.64 times 0.36 divided by 45. Oh. I don't know, what did you get? Dan, did you work it out? This one.
What do you need?
Well, I need the answer.
I got like slightly off, right?
Both.
I'll tell you what, I'll take over from here. 0.64 times 0.36, 0.7.3 is 0.21, square root of that is 0.45. Square root of 45.
The left side was.
What's that?
I know the left.
Okay, so 0.5.
This side.
78.
Other side like points.
Gotta be around
It's in the
0.78.
0.7.
I mean, if this is 0.5, then this one's 0.78. This is down 14. All right, I got $10 for you right here. Interpret it. Come on.
Oh yeah, nah, it's over. It's over.
Dan,
Damn.
if we continue. Go ahead, Brantley. Sample proportions to be between 0.5 and 0.78. I give you 5 if you can tell me the assumption. You don't know that one either. Come on, man, you're killing me. Dan, what's the
I'm
assumption?
not though. This is the farthest I've gotten on.
You are doing a whole lot better. You keep coming to the, you come Monday and Tuesday.
Nah, I know.
I'm telling you, we can get you out of this because it's not that hard once you understand the idea.
I'm not sure what assumption means.
Oh, okay. You don't do that. Something is normally distributed. Since n times p hat and n times q hat. He may not make you do this, Dan. Is greater than or equal to 5.
But
The sample proportion Dan, real quick, I'm gonna walk you through this one.
Yeah, thanks.
You wanna go ahead and stop that? Alright, so first thing we gotta do is draw a picture.